In Ann Arbor, Michigan, a normal morning turned chaotic when every traffic light at a major intersection flashed green at once. Horns blared, brakes screeched, and confusion reigned. An accident seemed inevitable. But this wasn't a random glitch. It was a deliberate demonstration by University of Michigan security researchers. With just a laptop and some off-the-shelf hardware, they remotely seized control of the city's smart traffic lights. Their goal: to expose a critical vulnerability before real criminals could exploit it. The city's wirelessly connected traffic signals were shockingly insecure. The researchers could manipulate traffic from a nearby coffee shop, showing how easily order could turn to chaos. This experiment was a wake-up call for city planners and cybersecurity experts nationwide. For years, cities focused on efficiency, installing smart lights to reduce congestion and pollution, while security lagged behind. The Ann Arbor hack proved attackers didn't need physical access. They could strike from afar, unseen. If a handful of researchers could do this, what could a sophisticated criminal or hostile nation achieve? Imagine gridlock across an entire city, emergency services paralyzed, or targeted accidents at key intersections. The demonstration wasn't just a clever hack, it was a preview of a new kind of threat. Our digital infrastructure, meant to keep us safe, could be weaponized against us. The line between cyber and physical safety had blurred. The message was clear. The systems guiding us through daily life were more vulnerable than anyone realized. The cost of convenience was a new world of risk, and the race to secure our streets had just begun. Today's traffic lights are no longer simple timers. They're computers running complex software at every intersection. Each controller, housed in a metal box on the street, processes data from sensors, loops in the pavement, cameras, radar, even emergency vehicle signals. These controllers adapt in real time, extending green lights for heavy traffic or activating walk signals for pedestrians. Older controllers ran obscure, hard-to-update software, but newer ones use familiar platforms like Linux. This makes them easier to manage, but also more tempting targets for hackers. If someone gains access, they can override all logic, ignoring sensors and controlling the lights at will. The real challenge for attackers? Finding a way to communicate with these brains remotely, without ever touching the box. As cities upgrade for efficiency, they often overlook security, leaving these powerful computers exposed. The intersection's controller is the final authority. Whoever controls it, controls the flow of the city. And as we'll see, gaining access is often easier than you'd think. The convenience of modern tech has opened new doors for those seeking disruption. The question is, how secure are those doors? The real power of smart traffic lights comes from their networked connections. Central command centers can monitor and adjust signals citywide, but this connectivity is also the main target for hackers. Older systems use secure, hardwired connections, but most cities now rely on wireless networks. Cheaper, but riskier. Many wireless deployments lack basic security, unencrypted radio signals, default passwords, and outdated protocols. In Ann Arbor, researchers found anyone with the right radio gear could intercept traffic data and credentials. It was like leaving the keys to the city's grid under the doormat. These vulnerabilities aren't unique to traffic systems. They're common in industrial control networks everywhere. Designed for longevity, these devices rarely get timely security updates. The result? A sprawling, powerful infrastructure, often protected by weaker security than your home Wi-Fi. The network that makes traffic smart can also make it dangerously exposed. Hackers don't attack blindly. They start with careful reconnaissance. They scout intersections, noting controller models, antennas, and labels, then research manuals and specs online. Next, they scan for wireless networks, using software-defined radios to hunt for the right frequencies. If the network is unencrypted, they eavesdrop with tools like Wireshark, capturing data, commands, and even plain text passwords. Even with encryption, patterns and device addresses can reveal system structure and weak points. Many older systems use outdated encryption, easily cracked with modern tools. The goal: turn unknowns into a detailed blueprint for attack. With enough information, hackers can map the network, identify vulnerabilities, and plan their next move. Reconnaissance is methodical, patient, and alarmingly effective. It's the first step in turning a city's infrastructure against itself. With a blueprint in hand, the hacker moves to exploit the weakest link. If default credentials are in use, access can be as simple as logging in. No hacking required. Wireless networks let attackers join the city's private grid from a distance, bypassing physical barriers. If passwords fail, hackers search for known software vulnerabilities, launching exploits to gain control. Sometimes physical access is possible. Controller cabinets may use standardized keys, easily duplicated. Once inside, attackers can reset passwords, dump configurations, or install malware for future remote access. The path to control is often shockingly simple. A single weak point can open the door to an entire city's traffic system. And once inside, the possibilities for disruption are endless. Hackers use off-the-shelf tools, many designed for legitimate security testing. Software-defined radios like HackRF1 let them intercept and mimic traffic system signals. Packet analyzers like Wireshark reveal unencrypted commands and passwords. Vulnerability scanners such as Nmap identify open ports and services. Metasploit automates attacks on known flaws. Once inside, attackers use command line tools or web interfaces, just like city engineers, to control the lights. The same technology that helps secure systems can be turned against them. With the right tools, a hacker can manipulate traffic from anywhere. The barrier to entry is lower than ever. Once inside, a hacker's options are chilling. They can gridlock a city by turning all lights red at key intersections, blocking emergency vehicles, and causing chaos. More dangerously, they can trigger green light all attacks. Every direction goes at once, risking deadly collisions. Subtle attacks are possible too, tweaking timings to favor certain routes, disabling pedestrian signals, or causing random glitches. Persistent malware can hide in controllers, ready to disrupt the network on command. These attacks can be one-off stunts or long-term sabotage. The city's traffic grid becomes a weapon, its safety features twisted into tools of disruption. The threat is real, and the consequences can be catastrophic. The only limit is the attacker's imagination. While Hollywood-style hacks haven't happened yet, real incidents prove the threat is no fantasy. In 2014, researchers exposed vulnerabilities in major cities' systems, default passwords, unencrypted data, forcing urgent security upgrades. In Los Angeles, a disgruntled contractor once hijacked the city's traffic grid, causing days of gridlock before being caught. In the Netherlands, researchers tricked smart bike signals, keeping lights green for cyclists and blocking all other traffic. Each incident triggered frantic patching and costly repairs. Vulnerabilities aren't theoretical. They're on our streets right now. Fixing them means sending technicians to thousands of cabinets, a slow, expensive process. Every breach erodes public trust and highlights the need for proactive security. The lesson: smart features bring new risks, and ignoring security is no longer an option. The stakes are high, and the clock is ticking. Cities and manufacturers are now racing to secure our traffic infrastructure. The first step: ditch default passwords and require strong, unique credentials. All network communications, wired and wireless, must be encrypted with modern standards. Network segmentation limits the damage if one controller is compromised. Intrusion detection systems now monitor for suspicious activity in real time. Regular security audits and ethical hacking tests are becoming standard. Proactive defense is replacing reactive patching. Securing our streets demands ongoing collaboration, constant updates, and vigilant monitoring. As cities get smarter, the battle to protect them intensifies. The challenge is clear: keep the lights guiding us home safe from those who would turn them into chaos.